Hello everybody at home. I'm going to talk you through next week's maths. On each of the slides you will see that I have put a little photo for each day to show you what your activity sheet looks like. However, do not try to use that sheet because the image is far too small. You'll notice on MS Teams that I have put a PDF version that I've got all the maths activity sheets as a PDF. So if you use the PDF, it will be much clearer for you to see. I have just snipped the little picture onto each slide so that you know which sheet to look for and there is no confusion. Okay, so remember to use the PDF. Hello everybody, so I'm going to talk you through lesson 9 out of 15, which will be the lesson that you will complete on Monday. Now, if you had good success on Friday with lesson 8 out of 15, again, this lesson builds on that knowledge from lesson 8, so you will be flying with this. Your do now is some revision of previous lessons' works. So you have got 6 questions whereby you need to use an efficient strategy to calculate the following addition equations. They are all 4-digit, add 4-digit. Some you will be able to do mentally. So for example, I'm looking at number 3 and straight away I can see that I would be using the method of round and adjust. I would be rounding 2,998 to 3,000. I can easily add 3,000 to 1,317 in my head, which is 4,317, and I now need to adjust. I need to take off 2 because I added 2 on to 2,998. So therefore, my answer would be 4,315. Looking at some of the other questions, again, round and adjust might be more appropriate. Partitioning might be more appropriate, or your good old friend formal method of addition might be more appropriate. However, we don't want to see the formal written method of column addition if you could use a strategy such as round and adjust, partitioning, or mentally. You only use a written method if that is the last resort and you can't use any of those more efficient methods. Good luck with your do now. For your independent task, again, we're going to be continuing with column subtraction now. But this time today, we will be regrouping in more than one column. So your activity sheet has 6 bar models. Remember, a bar model helps us to see the 2 parts and the whole. So if I talk you through number 1, my whole for number 1 is 6,734. I know one of my parts is 4,782. My whole, take away my known part, will leave me with my unknown part. Whole take part equals part. Just like part add part equals whole. So when I'm looking at this first calculation, I know I need to do 6,734 subtract 4,782. Thinking about which is the most efficient method, I'm thinking that I'm going to do this using column subtraction. I'm going to estimate my answer first though. I'm rounding 6,734 up to 7,000. And I'm also rounding 4,782 up to 5,000. So my answer will be approximately 7,000 subtract 5,000, which is 2,000. I know my actual answer will be roughly close to 2,000. When I use my written method of subtraction, there is regrouping in several columns. I'm going to talk you through that now. So I'm writing it out. 6,734. Subtract 4,782. When I have written it out, I'm taking care to line up my columns really carefully. I'm starting with my ones column. 4 take away 2 is 2. In my tens column, 3 take away 8 I can't do because I would end up with a negative. So I go to my hundreds column. I'm crossing out my 7 and replacing it with a 6, and I'm carrying my 1 over into my tens column. So now I have 13 tens subtract 8 tens. 13 subtract 8 is 5. I now go to my hundreds column. It's 6 take away 7, which I can't do because it would be a negative number. I'm exchanging and I'm crossing out my 6,000 and replacing it with 5,000, and I'm putting a 1 back in my hundreds column. I've now got 16 subtract 7 in my hundreds column. 16 subtract 7 is 9, and then in my thousands, 5 subtract 4 is 1. My answer is 1,952. These are harder than lesson 8 questions because there is regrouping in more than one column. I wonder whether you can solve 2, 3, 4, 5 and 6. For question 7, Max and Will are solving a problem. Who is right? Which answer is correct? Explain your reasons. Why is one of the answers wrong? Max says, when I subtract 546 from 3,232, my answer is 2,714. Will says, when I subtract 546 from 3,232, my answer is 2,686. They've both subtracted the same number from the same whole, but one of them is right and one of them is wrong. I wonder if you can work out and explain who is right and who is wrong. Good luck! Hello everybody at home. So today is Tuesday's lesson, which is lesson 10. Now, for your do now, again, it's revision of previous learning, and I want you to use an efficient strategy to calculate the following subtraction questions. So you have got 6 subtractions, thinking about which is the most appropriate method and the most efficient method. You might choose to do these mentally. You might choose to use column subtraction. You might choose to round and adjust. You need to choose the method that works best for you. However, sometimes you might be quite confident in those methods when we're looking at column addition. It can be a little bit harder with column subtraction, so take care. If ever you're unsure or stuck, go to your old friend of column subtraction. Okay, for your independent task, today we're going to be looking at subtracting a 4-digit number from a multiple of 1,000 and thinking about efficiency. If I put number 7 into a column subtraction, I end up with a bit of a problem. I wonder if you can tell me what problem I face when I put that into a column subtraction. I'm starting off with my ones column. 0 take away 9. Well, I can't do that because it would be a negative. Can I knock next door and exchange in my tens column? No, because there's a 0. Can I go next door into my hundreds column and exchange from there? No, because it's a 0. So I would have to go all the way over to the 5 in my thousands column, which causes a bit of a problem. Some of you will be confident in doing that and all of that regrouping. However, it's not necessarily the most efficient method. So I'm going to show you something. What would happen if I took away 1 from 5,000? What number would I get? Well done. I would get 4,999. Now, because I've taken away 1 from my starting number, I need to take away 1 from my second number to compensate for that shift. Because I've adjusted my first number, I need to adjust my second number because I'm shifting them by 1. Therefore, my answer will still be the same answer because I've just adjusted my numbers. What is 2,789 subtract 1? Well done, it's 2,788. So if I pop that on here, I'm now going to complete that column subtraction. You can copy it out and do it along with me if you'd like. 9 take away 8 is 1. 9 take away 8 in my tens column is 1. 9 take away 7 in my hundreds column is 2. And 4 take away 2 in my thousands column is 2. I get the answer of 2,211. If I went back to the original question and tried to complete this as a column subtraction, I would still get 2,211. However, this is an inefficient method because of all the regrouping and exchanging that you have to do. Have a look here. Do you have to do any exchanging or regrouping? No. I know which method I prefer. Remember, I've adjusted by 1, so I have to adjust my other number by 1. If you forget to adjust the second number by 1, your answer will be wrong. I wonder if you can have a go at 8 and 9 by yourself. Number 10. Sam, Lucas and Jemima are solving the calculation 7,000 take away 3,582, and they've used 3 methods. Sam has used this method, whereby he would put it into a column subtraction and have lots and lots of regrouping. Is Sam right to do that? Is Sam wrong to do that? Lucas has used the method that I've just shown you. He's taken 1 off 7,000 and he's taken 1 off 3,582. He has got the same answer as Sam. Whose method would you prefer to use, Sam's or Lucas's? Have a little think and have a go at both. They've both got the same answer. I wonder if they've both got the right answer. And Jemima has used a number line. Although it's a subtraction question, we know that subtraction is the same as counting on. And Jemima has counted on from 3,582. She's jumped up to 3,600. She's jumped up to 4,000. And then she's jumped up to 7,000. And she's got the same answer of 3,418. Who is correct? Or are they all correct? Can you explain how each child has solved their answer? Who is the most efficient? Then question 11 and 12 are a little bit tricky. You need to read them very carefully. They're word problems which involve lots of problem solving and reasoning. Good luck! Hello everybody, so welcome to Wednesday's lesson. Wednesday's lesson is lesson 11 of this unit. So looking at the do now, look at the bar model with 2 out of the 3 values labelled. I've asked you what is known, what is unknown, and what could the equation represent. So on the bar model, we've got 2 known parts. I know one of my parts, I know the other part. Therefore, my whole is unknown. Part add part equals whole. Say it. Part add part equals whole. Just like my whole, subtract my 2 parts, would leave the other part. Whole take part is part. I've asked you what could this equation represent. I wonder whether you could make a word problem based on the 2 numbers that I have given you. Remember to solve the equation so you can tell me what the unknown part or my whole is. For your independent task, you're going to be completing the word problems below and drawing a bar model for each problem before calculating the answer. The bar model will help you to work out whether you need to add the numbers in the word problem or whether you need to subtract them. I've not told you for each one whether you'll be looking at addition or subtraction, because that's me doing the work for you, and we don't want that. So, I have been quite sneaky in the way that I've phrased the question. I'm going to talk you through the first one, and then you'll do the others independently. So, number 1. A Parisian bakery baked 2,645 baguettes in the morning. They had sold 1,972 of these baguettes by lunchtime. How many baguettes were left for after lunchtime? I wonder, is it a subtraction or is it an addition? Think about the language that I've used in there. How many did they start with? How many did they sell? How many did they have left? Take a minute to think, is it addition or subtraction? Well done, it's a subtraction. I can prove it to you by drawing a bar model, and this is what I want you to do for each one. I know my whole is 2,645 because that's how many they started with in the morning. By lunchtime, they had sold 1,927. So how many did they have left? Okay, I've popped it into a bar model. You can see my whole is 2,645. One of my parts is 1,927, which means my remaining part is my unknown value. I can clearly see I will need to use a subtraction to solve that. Whole take part is part. Notice how I've made this bar bigger, because if this is 1,927, I can estimate what this is. I'm rounding this to 2,000, I'm rounding this to 2,600. I know that my estimate will be around 600, which is why I've made that bar a lot smaller than that bar. Try and ensure that your bars are representative in thinking about scales. We don't want a really tiny bar if it represents a big number. I'm going to think about what the most efficient method is to solve that question. Looking at the numbers, I'm going to use column subtraction. I'm popping it into a column. Notice how I've lined up my columns neatly and correctly. Okay, in my ones column, 5 take away 7. I can't do, it would be a negative, so I'm exchanging. I'm going to my tens, I'm crossing my 4, I'm replacing with a 3, and I'm putting my 10 in my ones column there. I've now got 15 subtract 7. 15 take 7 is 8. 3 tens take 2 tens is 1 10. 600s take away 900s, I can't do. I'm going to exchange and regroup. I'm crossing my 2 for a 1 in my thousands, and therefore in my hundreds I've got a 16. 16 take away 9 is 7. And finally, 1 take away 1 is nothing. My answer is 718. When I compare that with my estimate of 600, I know they're very close, so I must be correct. I wonder whether you can solve 2, 3, 4, 5 and 6. Remember, using a bar model will help you to understand whether it's an addition or a subtraction. I want to see your bar model, please, and I want to see your estimate as well as your actual answer. Good luck! Hello everyone, Thursday's lesson, lesson 12 out of 15. It's nearly half term, we're there, let's keep going. Okay, for your do now, I've given you a bar model. I've given you all 3 elements of it, both the part and the whole. Could you write me a word problem to represent this bar model? You could give me an addition word problem and a subtraction word problem. Okay, in fact, I'd like you to give me both. For your independent task, what I want you to do is complete the word problems by drawing a bar model for each problem before calculating them and solving them, similar to yesterday. I will talk you through one example again. So, on Thursday, Pat walked 3,138 metres from her hotel to the Louvre Museum. Remember, we're set in Paris, which is this topic is all about France and Paris. On Friday, she walked 2,346 metres from her hotel to the Eiffel Tower. How much further did Pat walk on Thursday than Friday? On Thursday, she walked more than she walked on Friday. So I'm thinking about this in a bar model. Thursday, she walked 3,138 metres. Friday, she walked 2,346 metres. Again, in my bar model, you can see my top one represents Thursday, my bottom one represents Friday. How much further did she walk? We want to know the distance here, how big this bit represents. So I can quite clearly see now that I'll be using subtraction. Well done, you got it right. Because I'm subtracting my whole, take away my known part. I'm going to put it in a column because looking at those numbers, that will be the most efficient method. There might be regrouping in more than one column, but I know you'll be so confident with this by now. You don't need me to show you. Remember to estimate your answer. I would estimate that by rounding 3,138 to 3,100. I would round 2,346 to 2,300. So my estimate would be about 800 metres. Remember, I want to see an estimate, a bar model drawn, and the actual answer. 3 things for every question, please. Repeat for 2, 3, 4, 5 and 6. And then question 7 is a bit of a challenge. You'll be fine with it. Good luck! Hello everyone, it's Friday's lesson, and not only is it Friday, but it's the half term as well. Very exciting. So let's get this last lesson done and then we can relax. Looking at your do now, I have put 2 bar models and I've put A, B, C, D, E, F to represent different parts on the bar models. For the first bar model, a car travels 117 kilometres from London to Calais and then 293 kilometres from Calais to Paris. How far did the car travel in total? So I've given you the three numbers. You need to work out which number goes in position A, which number goes in position B, and which number goes in position C. And write them at the bottom, please. Similarly, the same again for D, E, and F. You won't actually need to solve these because if you read it very carefully, they've been solved for you. But what I'm interested in is, can you label the parts and the wholes properly? Read the question carefully to work out what your parts are and what your wholes are. For your independent task, we're going to be looking at word problems again using bar models. However, today it gets a bit harder because they're two-step problems and they involve addition and subtraction. So, for number one, I'll talk you through it. It says, on Thursday, 3,572 of the total number of tickets sold were adult tickets. How many were children's tickets? And if you look at the table shows the number of tourists who bought a ticket to go on the many tour buses in Paris in a week. So we've got Mondays, Tuesdays, Wednesdays, all the way to Sundays. And we've got tickets that were bought in the morning, in the AM, and the afternoon, and in the PM. So on Thursday, 3,572 of the total tickets were adult tickets. How many were children's tickets? Well, we need to think about the total number of tickets on Thursday because we need to know how many were sold all together on Thursday. So step one is to add up the AM on Thursday and the PM on Thursday. So the first part is an addition. I'm not going to help you with that addition. I know you'll be fine with it. I'm looking at the numbers though, and I'm thinking I'm definitely going to use a formal written method of column addition. Once we've got that answer, which is going to be approximately, well, let me see. I'm rounding 2,463 to 2,500. I'm rounding 2,837 to 3,000. So when I add them together, I get approximately 5,500. So my whole for Thursday will approximately be 5,500. Of that 5,500, 3,572 are adult tickets. How many are children's tickets? Then I need to subtract 5,500, subtract 3,572, approximately. I'm rounding that to 5,500, subtract 3,500, which is approximately 2,000. The actual answer will approximately be 2,000. I could draw two bar models to show you what I've just done. My bar model would first be an addition. So I would have 2,463 add 2,837 to equal my whole. So my first bar model would look like that. Part, add part equals whole. Then I would need to do a column subtraction because once I've got that whole, I would need to subtract that. That would be my starting number, and I would subtract the adult tickets, which was 3,572. So whatever you get for your actual answer, subtract the adult tickets, will leave you with the child tickets. So my whole, my adult tickets, which will leave me with the child tickets. You'll be a superstar at this, I know it. Good luck!